Ladies and gentlemen, thanks for your interest in our subject. I just wanted to note that we are running an international network we call AgriBenchmark Horticulture or AgriBenchmark Specialty Crops. One of the main objectives of this network is to regularly compare costs of production, revenues, gross margins, and stuff like this. So we are comparing different wine growing regions, and this research is an example how our methodology can be applied additionally to our regular analysis. So the subject I was dealing with in this project, together with my colleagues Kathrin, Strohm, Hildegard, Garming, who is around here as well, and Andrea, is on extreme weather events, because due to climate change we expect them to increase and to cause damage in wine grape production. So, as you can see here on the slide, that's the effect a hailstorm can cause to wine grapes. So you can imagine that severe losses in production can result from such hailstorms. So what are the main extreme weather events we are faced with in grape production in Germany? These are at first hailstorms. The second, it's late frost during flowering stage, and also droughts. Let me introduce the problems involved with hailstorms a little bit more in detail. As you can imagine, and I mentioned it already before, is that hailstorms can cause severe crop damages. They are spatially very restricted, and that's why it is very hard to predict in advance where hailstorms will occur precisely. So this is a big problem when dealing with this extreme weather event. What about late frost? Late frost impact wines when flowering. They can also cause severe damages in all these areas which are affected. Regarding late frost, we can observe two different developments. The first development is that in traditional flowering periods, due to the climate change, the temperatures increase, which as a consequence will lower the late frost danger. But on the other hand, due to the average temperature increase, the flowering starts earlier as compared to earlier days, which in turn increases the late frost occurrences. The combined effect of all this, of these two effects is still not known. Drought is relevant throughout the whole growing period and may lead to reduced growth and also to yield losses. So what are the effects of higher frequencies of extreme weather events on farm level? On one hand, they increase production risk due to potential crop losses, and on the other hand, they impose costs on the grape grower, costs for the mitigation measures. We are faced with a severe problem, and this problem is the lack of data. The probabilities, for instance, the probabilities of the occurrence of extreme weather events, such as hailstorms, is not known, and this is true for historical data and for future data as well. And on the other hand, the extent of the damages is also not known yet. That means very important data for such kind of analysis I'm going to present here is missing, and that's why we choose the methodology I'm going to present soon. So the objectives of our study is to identify efficient mitigation measures against the extreme weather events I just introduced to you. What are our data sources? We rely on regional statistics. We included the knowledge of advisors for viticulture, for grape growing. We conducted focus group interviews of wine growers, and we asked experts to estimate probabilities of the occurrence of extreme weather events on one hand, and on the potential to identify the potential damages of such weather events on the other hand. We applied the methodology we use in this agri-benchmark approach, what we call the typical farm approach. It was introduced to you yesterday already by my colleague, so I hope that I can skip this slide. And we modeled typical farms for two different, quite important wine growing regions in Germany. One is Franconia, in German Franken, where they aim more at producing bottled wine. And the other region is Rheinhessen. Rheinhessen, there lots of bulk wine is produced. Or not? Our analysis follows a three-stage approach. In the first step, we compare the production system in 2013 with a hypothetical situation in 2013, including one of the extreme weather events. That means we include one extreme weather event after the other and calculated the differences. The second step was to compare this hypothetical situation with including a mitigation measure against this extreme weather event. And the last step was to calculate the next, we used the gross margin, that's what I need to mention before. We used the gross margin in the first step to identify the benefits of the mitigation measures. And in the third step, we calculated net present values of the gross margin over a period of 30 years, which is the usual lifespan of a vineyard in Germany at a discount rate of 3.5% in order to compare the efficiency of the different alternatives we are going to analyze. So what do our typical farms look like? In Rheinhessen, we modeled a 30-hectare farm, which is family managed and producing bulk wine, as I mentioned before. The main varieties, grape varieties, are presented here. The labor requirements amount to 162 hours per hectare, and the gross margins amount to nearly to 6,600 euros per hectare in Rheinhessen. Contrary to that, the typical vineyard in Franconia is smaller. It has only 10 hectares. It is also family managed, but the main production goes into bottled wine. The main grape varieties are displayed here as well. Because of higher quality demands, the labor requirements are much higher compared to Rheinhessen and sum up to 460 hours per hectare. Due to the higher sales prices of bottled wine compared to bulk wine, the gross margins are also higher, which are close to 10,000 euro per hectare in Franconia. Now I would like to come to the results. And before that, I have to mention that additionally to the practices to be observed in the two regions, we also modeled a new production system, which is called minimum pruning trellising system, which is established on research level already in research stations, and some grape growers also included this in their vineyards, but it is still in the process of being introduced into the wine grape growing practices. So that's why data on this practice is also missing to some degree. Please let me introduce the extreme weather events we 2 minutes? Okay. The extreme weather events we modeled two different hail scenarios. The first one is more severe than the second one. And we also modeled two different late frost scenarios, and here as well, the first one is more severe than the second one. Drought is not analyzed. What are the mitigation measures? Against hail, we included in our analysis the hail insurances on one hand, and on the other hand, the minimum pruning system. And for late frost, minimum pruning works as well. But on the other hand, you can invest in wind machines, and you can also use, in smaller areas, frost-protecting candles. So these are the results for Rheinhessen. If you compare the status quo with the minimum pruning, based on our assumption, minimum pruning increases the gross margin only slightly, but it still does. For hail, the hail insurance is effective in both hail scenarios based on the criterion of gross margin. And it's similar with minimum pruning system I did not highlight here. If you look at late frost, the investment in wind machines is profitable, but only in the first, that means in the more severe late frost scenario. If we compare the results based on gross margins or the net present value of the gross margins, you can see that the results may differ. For instance, in the hail scenario 2, including the hail insurance, over time it is not worthwhile to conduct or to buy an insurance, as you can see with the net present value of the gross margin. I think I have to skip Franconia and come to the conclusions. Hail insurance is advisable from our point of view in areas which are really prone to higher probabilities of hailstorms. And this is true in particular for risk-averse decision makers. On the other hand, you also have to consider that hail insurance has a liquidity effect, which, however, was not subject to our analysis. Against hailstorms and late frost, the minimum pruning system is potentially beneficial for bulk wine producers and also for grape growers, but as it is still in its research stage, maybe we have to adjust our assumptions. Investments in wind machines are meaningful to counteract late frost in suitable, that means in flat areas. And because of high investments, you either have to cooperate with your neighbors or you need to run fairly or comparatively big farms because of the widespread frost protecting candles can be suitable as an emergency measure, but only in small plots because of the high labor demand. In general, the selection of the mitigation measure should be grounded on a rational decision basis. That means you should calculate your results over time, calculating the net present value of the gross margin, and should not stop what is usually done when you discuss with advisors, comparing the different gross margin, because you may end up with different results. The nature and extent of risk management practices differs individually, as we know. It depends on framework conditions, it depends on the risk attitudes of the decision makers, and so on. I mentioned it before, that data is missing, very important data is missing. That means we have got some recommendation for further research here. Thank you very much.